All right, so I hope everyone's doing okay. We got the first week out of the way. Now we're going to go ahead and start with 2.4, limits at infinity. Now, there are two types of limits that we can actually explore when dealing with infinity. The first one are infinite limits. These limits occur when a function value increases or decreases without bound near a point. So what you're going to be looking at here is an x value, and you're either going to get like positive or negative infinity for an answer. The other type of limit is going to be limits at infinity, okay? And this is when the independent variable increases or decreases without bound. So the difference here is, and I'm going to write this in red for us, is you're going to have the limit as x approaches, let's say, infinity of some function, or the limit as x approaches negative infinity of some function. In other words, that independent variable is either increasing or decreasing without bound, okay? So, as always, we have a big definition here. So let me go ahead, let's zoom in a little bit. So this can be found in your book. It's in 2.4. I don't remember exactly the page. But infinite limits we're going to speak about first. So suppose f is defined for all x near a. If f of x grows arbitrarily large for all x sufficiently close but not equal to a, we're going to write the limit as x approaches a of f of x equals positive infinity. Okay? So what we're looking at here is a situation where as you get closer and closer and closer to some arbitrary value a, okay, our outputs are going to get larger and larger and larger, and they grow without bound. Hence, we say positive infinity. On the flip side, if f of x is negative and grows arbitrarily large in magnitude for all x sufficiently close but not equal to a, we write the limit as x approaches a of f of x equals negative infinity. So once again, the idea behind this is, as we get closer and closer and closer to some arbitrary value a, we're going to notice that f of x is approaching negative infinity. So let me go ahead and let me show you an example of how this works. Okay, so we have just a really basic problem right here. All right, and let's see, let's read this real quick. So the graph of f is given below and has vertical asymptotes x equals 1 and x equals 2. All right, let's find the following limit. So I'm going to go ahead and start writing them out. So let's find the limit as x approaches 1 from the left of f of x. Well, if you think about it, we're approaching 1 from the left, so we're coming this way, which means my limit is going upward, and that is going to equal positive infinity. Okay? Now let's go ahead, let's look at the second part. Let's do the limit as x approaches 1 from the right. Well, we're approaching from the right now, and notice right here, my values of x my values of f of x are getting larger and larger and larger, and that equals positive infinity as well. Now for the next one, and maybe you can guess where I'm going with this. If I want to evaluate the limit as x approaches 1 of f of x, let me separate these. That means I am approaching from both sides. And notice that both limits, the left side and the right sided one-sided limits, equal the same output, infinity. So this is going to equal positive infinity as well. Now, let's look at the other asymptote that we have here in this situation. So the limit as x approaches 2 from the left of f of x. Ooh, I forgot to write f of x up there. There we go. So the limit as x approaches 2 from the left of f of x. Well, I'm approaching 2 from the left, so that's this way, which means I'm going downward, so that's going to be negative infinity.